All right, here's a quick tutorial on how to factor by grouping. So you want to use factoring by grouping when you have an even number of terms. So I have 4 terms here. Terms are the things that are separated by the plus and minus signs. So I have 4 terms here. I should try to see if it'll factor by grouping. And the way I'll do that is I'll kind of follow these steps here. So the first step is to split your terms into 2 groups. What I mean by that, maybe I should say 2 groups of 2 terms each, although that's only if there's 4. What I mean is split this up. So there's one group, there's the other group. 2x cubed minus 6x squared is one group. Negative 5x plus 15 is the other group. So step 1, just split them into 2 groups. 2 even groups maybe. And then step 2 says look at your first group, this 2x cubed minus 6x squared, and factor out the greatest common factor from it. What I mean by that is look at 2x cubed minus 6x squared and look for the largest thing that those two have in common. What is its greatest common factor? In this case, it's 2x squared. And the reason it's 2x squared is because 2x squared goes into 2x cubed, and 2x squared goes into negative 6x squared. And if I pull out a 2x squared from 2x cubed, I'm left with just x. And if I pull out a 2x squared from negative 6x squared, I'm left with negative 3. If you're not sure if you did that right, you can take this 2x squared and distribute it back into the parentheses, and you should get back where you started. So there's step 2, factor out the greatest common factor from your first group. Step 3 says factor out something from your second group here, but make sure that what you're left with, what you have in the parentheses when you do that over here, is the same as what you had in the parentheses over here. What I'm saying is pull out something so that you're left with x minus 3 over here. And what that something is in this case is a negative 5. If you can't find a something that makes this work, either you made a mistake or you were given a problem that doesn't factor by grouping. But in this case, if I pull out a negative 5 from negative 5x, I'm left with just positive 1x. And if I pulled out a negative 5 from positive 15, I'm left with negative 3. So what I'm left with in the parentheses over here is the same as what I had in the parentheses over here. So the end of step 3 is when you have this when you factored out something from each of your groups so that the leftovers are the same. And then in step 4, all you have to do is think about this like it were two terms. Here's one term over here, and here's the other term over there. And each of these terms has an x minus 3 in it. So if they both have an x minus 3, we can factor out that x minus 3. I can pull out the x minus 3 from this term, and I'll be left with just 2x squared. And I can pull out the x minus 3 from this term, and I'll be left with just negative 5. And so what I've done is I've factored this original polynomial into this form here. If you're not sure you did it right, you can check your answer by multiplying these 2 binomials back together and making sure you get where you started. I'm pretty sure we did it right, so maybe I'll just leave this and go on, do this a couple more times. Maybe I can do them a little bit quicker. In this second one, same idea. Okay, here's my first group, here's my second group. Greatest common factor here would be 3x cubed. If I pull out a 3x cubed, I'm left with x over here and minus 3 over here. And then I want to be left with x minus 3 over here. Wait, I already have x minus 3 over here. I know, but up here in step 2 it says, or in step 3 it says factor out something from the second group. So you have to pull out something. What can you pull out that won't change anything? You can pull out a positive 1. And it's important to pull out that positive 1. Well, it helps to pull out that positive 1 because it'll serve as kind of a placeholder in the next step. So what I've done, step 1, split them into 2 groups. Step 2, find this greatest common factor and see what you're left with. Step 3, pull out something so that your leftovers are the same. And then step 4, factor out those leftovers. So pull out that x minus 3 from both terms. We're now left with just 3x cubed on this side and just positive 1 on this side. And maybe you note the importance of this placeholder here. If you hadn't written anything there, you might forget to write something here. So this factors to this. I guess I can put equal signs in there to show it. And one more example, I don't know, just to show that you can do this when you have more than 4 terms. You can even do this when you have 6 terms or 8 terms, any even number of terms. You can give it a try and see if it works. If I split these into these 2 groups, my greatest common factor from my first group is just an x. And if I factor out that x from those first 3 terms, I'm left with y squared minus 5y minus 6. Then if I look at this next group, these next 3 terms, I want to factor out something so that I'm left with the same leftovers. That something ends up being a -2. So if I pull out a -2, I'm left with y squared minus 5y minus 6. And so now what I have are two terms. Here's one of them. Here's the other one. And they both have this y squared minus 5y minus 6 thing in common. So using factoring by grouping, I get that this is equal to this. Should I do it? Turns out this can okay, I'm going to switch colors here. We're done factoring by grouping here. That's the end of the factoring by grouping. Turns out that this can, this factors even further. This is what's called a quadratic trinomial whose leading coefficient is 1. I have a separate video that shows you how to factor those. But what you'll see if you watch that video is that this actually factors to y minus 3 times. No, it doesn't. Let's see, does it factor to anything? Y minus 6 and y plus 1. Yeah, that's better. This turns out factors to this, although that's not factoring by grouping. So getting from this blue line to this red line is not factoring by grouping. It's something from a different video. But I just wanted to finish it up here to show you that this does in fact factor a little further. So I guess that's the end of factoring by grouping. Something that you might find interesting, maybe you don't, so this is kind of some bonus material here, is that if I had grouped these a little bit differently, if I had grouped the 2x cubed, maybe I'll write or, with the negative 5x, and then what that would leave me in the other group is negative 6x squared plus 15. If I had grouped this a little bit differently, here's one group, here's the other group, things are going to look very different. My greatest common factor over here is just an x. And what I'm left with is 2x squared minus 5. But it turns out that over here there'll be something that I can factor out that will leave me with 2x squared minus 5. In this case it's negative 3 that leaves me with 2x squared minus 5. So even if I group them a little bit differently, factoring by grouping will still work. I now have two terms that both have a 2x squared minus 5 in them, so I pull that out and I'm left with x minus 3. And what you'll see is even though the steps look different, you end up with the exact same answer. Kind of interesting. It turns out you can do that here too, as long as you don't group 3x to the 4th and the negative 3 together, because then the powers won't work out right. If we group that, if we make that our first group and this our second group, things will still work out fine. We could pull out an x here and be left with 3x cubed plus 1. And pull out a negative 3 here to be left with 3x cubed plus 1. And now we have two terms that both have a 3x cubed plus 1 in them. And if we pull that out, we're left with just x minus 3. So just as an FYI, there's other ways you can group things to make things work out. Turns out this one you could even group it into 3 groups of 2. Sure, why not? I'll show you that. Again, this is all bonus stuff, not things you have to do. But if we had grouped this as, let's see, xy squared minus 2y squared minus 5xy plus 10y minus 6x plus 12, if we had made this 3 groups, we can still kind of use our method. We can look for the greatest common factor here. In this case, it looks like it's y squared. And if I pull out a y squared, I'm left with x minus 2. And then x minus 2 becomes our leftovers. We're trying to be left with x minus 2 in all 3 of these. Turns out we can do that. If you pull out negative 5y from this second group, you'll be left with exactly x minus 2. And if you pull out negative 6 from this third group, you'll be left with x minus 2. So now what I have are 3 terms, and all 3 of these terms have an x minus 2 in them. So I can pull out that x minus 2, and if I do, what I'm left with is y squared minus 5y minus 6, which is the same thing, well, that I got here. And then this factors down to here if you want to go further. So I just wanted to show you that there's some freedom in how you do these. You can group things a little bit differently, but you don't need to be able to do these multiple ways. Just do them the one way that's the most obvious to you, and you'll be good with factoring by grouping.